All right, all right. Hello once again. So today we will look a little bit deeper into the first subject, which I believe is pretty important in terms of studying computer science in general. And second of all, I don't want to kill you with boredom, with a lot of the uh, uh, theory behind it all. So I just wanted to start with the little bit more um, practical approach. And trust me when I say that we're not going to go in depth with what you would actually study once you start studying it in the university, or if you're on your own, go ahead. But um, yeah, we're just going to scratch the surface of it so you can have a little bit deeper understanding um, of what you might come across when you start uh, digging into subject like compilers, or a little bit more lower base code, which C++ is. So today we will be focusing on C++, and not only that, but uh, we're not going to look what variables are and etc. I mean, that's something that you can look up everywhere. There are different websites and etc. which would tell you the same. Basically, what a variable is, you would look something like that. Int b is equal to, I don't know, 5. That's all you need to know for now, because I don't think anything else would be important. And to be honest, in my opinion, this is the most uh, useless part of it. Also, we're not going to look even a bit at what variables are, what um, the different variables are, and etc. Um, we're neither going to look in this particular uh, mm, class, let's call it, or in this particular video, we're not going to have a look at what the two dots, or basically the scope operator is. We're just going to look at some base examples and base functionalities of what and why we should know C++ on first place. And a lot of people jump straight to a little bit of a higher level languages, which do not basically have the abilities of C++. So, what are the abilities of C++? You might ask. Well, C++ is kind of a middle level language, and you would say, what does that middle level? I want the advanced part. I want the difficult part. Give me where the money are. I want to be in the money. Well, hold on your horses, because C++, C++ is a middle level language because it can operate and basically make everything with the memory of an of a computer. Let's get to the computer part. So if you're starting to study C++ and you don't know why you're studying it, well, its biggest advantage is that it can work with the memory of a PC, which is a programmable computer. So, what does that memory? Why is it so important? How would that help me in when you anyway? So, in today's video, we'll take a look at the first thing, which is pointers. And how does how exactly does those two get to have anything in common? So pointers, what is a pointer? So C++, you can make variables, you can make all of that, you can even create a game with it. But how would that all work? How would that all happen? Where does the magic come from? And you would ask, for example, why am I downloading a game on my computer? Why cannot I just, log in and start playing it online? Why should I have an exe file on my computer, for example? Well, it all has to do with the memory of your PC and the random access memory. We'll get to there as well, but in this course, we'll just start with the basics and why it's important. So, let's continue with what pointers and references are. It's very important for someone to, when you create a variable, to know where that variable is stored, because afterwards, well, that's why you have to know a little bit of knowledge of what is a memory of a computer, what is an operational system, how it works, and so on. So we'll get there, but just we'll go with one step at a time. When you create a variable, for example, just like the one we created earlier, int b is equal to 5. Well, where does that variable is stored, and how is it stored? Well, it's stored in a memory. Let's look it as such. And what are we saying? That we want a variable called b to be of type integer. And what does the computer do? Well, it says, all right, I want you to allocate memory for integer, which is 4 bytes. So these are the 4 bytes, which, we're not going to go in depth what bytes are, what bits are, and etc. So we have 4 bytes, and we have an address of that memory. And this address could look like something like F4BC49 or whatever, 8. And we know that if somehow we go to this very address, somehow, we don't know how, we'll get the amount of 5 for the variable named b. So this is b over here. And so why is that important? Well, it's important because that's how actually you make, that's how a computer actually works. If you store a file, you would want to use that file once again someday. And what do? You just go just like on the URLs of inside the web, you just write down a certain address and it returns you a certain page. Well, all of that, when it's done to a much lower levels, well, here is the same thing. So there should be a way of getting that value. So what is a pointer? So pointer is actually a variable, for example, pointer, which can refer to the address of a variable. So here we go. That's how with this reference, let's say, we can get the address of the variable b. So this would actually return us 5. So when we want to return or get basically the address of something, there is a way. So if we want to see out variable, let's say p, just the variable p, that would give us the address. But if we don't want the address, but we actually want the value, we will dereference it with the star once again. So here is the base, just the base of how we can store and get values. So there is also another way of having variables, and this is by the reference operator that I showed you over here. So if we create an integer of reference p, then and it is and well, not p, but let's let it be r, and it is equal to b, for example, this will actually make so-called magic. So well, this will kind of this will create a reference. So if you're having this memory over here that we have allocated, and we want to have the same value 5, but we don't want to use more memory because that's all we got. We don't have this part over here, we don't have it, and we just want to make as little or use as little space as possible. We will just create a reference, which is basically a way of saying that this r is going to point to the very same place where b is pointing, the address. So here we're not working with the actual value, but we're only working with the address. And this is a very powerful tool because now you understand how something that is or maybe you've heard of virtual of vtable, of virtual memory, and so on. These are all smart ways of making something that does not exist, because here we just wanted another variable that is called r, and we want to use it for something else, but it will use the same address just like our b. And this way, if we want to return 5 somehow, and we want it to be stored somewhere so we know and can keep track of it, we will no longer need to declare another variable, but we will just declare a reference to it. So basically each and every operation that we currently did is when we create a program, the program actually runs by the program runs by having allocated a certain amount of memory. Let's say this block of memory is allocated for running our program, which is like, you know, hashtag include iostream, input output stream library using namespace std standard, the standard scope, and then int main, and so on, so on. So when we run it on our computer, when we run so the standard space, and when we run it on the computer the computer should know how much memory to allocate, and this is what memory of this program looks. It looks at all of those not shell but all of the decorations and how much they cost. So this one is 4 bytes, this one is I don't know how much bytes, and the rest are as much bytes. So let's say a total of whatever bytes, and here is the stack. The stack keeps track of everything that basically it's the scope of the computer and how much memory it would use. So the program, and we should know what a program is. It's basically algorithm or something that has input and output, and it does some kind of a job, and it ends with a certain result. Let's go, and that's why you have the return 0 of the variant. So what is the stack? Well, the stack is getting everything that is needed, and it is input here. So this variable and the space for the reference, which is also here, but it's much less because it's just reference. It's just one value r, and it points for the memory of the variable b. So it's not much. It's almost like 5 bytes for now. So we're looking at that, and trust me when I say, when there are games, when there is something more, sometimes the program does not know how much space is needed for it to run. So that's why it's important to know that there is also another memory inside the computer, which is called the heap. And we'll talk about heaps, and so on much further, but for now just look at it as a place in the memory which can allocate as much as needed. So the heap might continue for much longer, and at that point, if you continue using it in a kind of not best way or bad way, or I don't want to say wrong, but most of the time it would be wrong if you continue getting more and more and more. You should be very careful with it, and because this can make your computer crash, and this is how different kind of malwares, different kind of attacks are done, exactly by using your heap memory and doing bad stuff with it. Alright, so that's all we know for now, and we are continuing with the next part of why we should know all of that. And the next part is let me just take a look at that. So we explained what pointers are, and let's say that we want to make an array. So int array. Well, what can we do at this very point? Why are we even writing the star before an array? Of course, we can do that as well. But what is the difference, and what is it actually? We're not going to go in depth with what an array is. Once again, this course is for people that already have some knowledge but don't know how to explain everything to themselves and so on. It's much more difficult than it looks, I know, but we're not going to have a look what an array is, what are the different ways to declare an array, and so on, blah blah blah. We're going to look at the pointers and why they are so important in C++ and where does the magic in C++ come from. Okay, so we have an array of something and we want to create it with maybe you've seen it with a star. And what does that even do when we write new int and let's say 5? What does that even mean when you take a look at it? You've probably seen it, but you're a little bit unsure, or etc, 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 and you just want to know it to the extent that you know how it actually works. So here we're declaring a pointer to we're creating a variable that is a pointer, right? Because it's the same thing. You can take a look over here and it's basically the same. It is the same. So it's very important that for arrays, well, it's something like a theorem, and this theorem means that a pointer, that an array, the first element of an array is actually address for the whole array. Well, that is correct. That is absolutely correct. And why? Because in here we're telling the compiler that it doesn't know yet, but every time we declare a pointer and we assign value it with new, then it tells the heap that we want to use its memory instead of the stacks. So inside new keyword, it's an important keyword, very important keyword. The new word basically tells that we want to assign what? Well, more memory, 5 more elements that can get each one of them of 4 bytes. So 4 bytes, 4 bytes, 4 bytes, and the total of 20, right? 4 maximized by 5. So 20, right? Well, that is absolutely correct. And right now you can see how dangerous that is, because we're using a memory that was not assigned for this program in the first place. And this memory is taken from somewhere. We don't know where exactly, but it's taken from somewhere. It might be taken by credit, it can be taken by whatever, blah, blah, blah. But once we finish, we don't care where it's taken from for now, but once the program finishes, we want to remove it, and that basically is done by the word delete. So we want to delete this memory allocated for the array of 5. Of course, after we've created this, we're not going in depth with it, of course, blah blah blah. We can do stuff like array 0 or 1 is equal to, let's say, 4, this one is to 15, you know, until 3, 6, 8, whatever the number of 5 decimals is, because it has a floating point and etc. We're going to talk about this later as well. That how the memory is used inside variables. We'll talk about we're going to talk about, well, uh, bit operations, and for example, when you want to have another bit, or basically summing integers, there are certain ways in which you can do that. There is the 1 and 2 in advance, which adds like 1 over here, but we'll talk about this later. So for now, let's talk about how the references are used. So for example, if you create a function, let's say a function that needs that kind of memory from the stack, and you're using references to it, well then they're functional and they're formal and factual variables that are passed for a certain method or function. Well, there is a difference, but we'll talk about it later as well. So they're just like I said, formal and factual. They are formal and factual variables that are passed inside each and every function. Let's say you want to create a function that adds two decimals, double A and double B, and it does something. Well, when you declare the function, the formal parameters are the ones that are used. So it's always good practice to pass them by reference, what we just said, because the variables that are passed, they will be kind of the same variables that we're going to use, but we're making a new stack each and every time we call the function. So what I mean by that is that somewhere underneath the code we'll be using we already have the factual variable. So we have int a, which is equal to 5, and we have double b, which is equal to 10, and we want to pass them to this function add. We cannot pass, of course, integer to a double. We'll talk about that later, but that's when you use template functions, and you can insert here t, but never mind. That's, once again, I'm just saying that we're scratching only the surface in this video by me explaining it, but just know that there are much smarter ways in which you can do a lot more with computers, maths, and memory and algorithms and so on. So smart people have already come with such ideas that make everything much more efficient. So we want to use the function in which we will call the function by its actual parameters, which are, we can even write down 5 and 10 over here as well. That will be the factual, but let's call A, this is double, and B. So right now we will create a new stack inside the stack, well, like a new, let's call it just new block, a new block that will call the function, but it will call the function by just using the function, and you can see what happens here. This A creates a double, which can be A, and this can be B. This will create a reference to that variable, but not actually using the variable, which is very important because that way we can do everything that we want, but in the variant we will substitute the actual value of A, because if we do that without reference, what will happen is that no change would occur to A, because this is an independent function when it comes down to this very memory, and this part over here wouldn't know for the different variables inside the very same stack. And this is something really important that you have to understand, maybe not from here, but you definitely have to take a deeper look at it, how it works and why it's very important. And this is the base of basically knowing how all and every programs work on first place. So let me just all right, so okay, so we will continue with just a little bit more of explaining what and why all of that is a little bit important. So for example, you want to create something that is, you know, something much deeper and higher level of structures and space and so on. So you want to do that inside a computer. So for example, you want to create kind of a game inside the 3D space. You don't have to know what and how that will look like some way, but you just want to know where to store the memory, where you want to store the memory of these variables that occur throughout your game or throughout the simulation or etc. So you just want to make the so-called visualization inside the memory. So how we're going to make that, because that's going to change constantly. You know, you cannot just write down I want because if you want infinity, then the answer is infinity. But if you want a certain amount of storage, and let's say that storage is 100, but you're going to use sometime only 10, sometime only 12, but you just want a certain amount, then that's okay. That's one approach. But if you want to use it using the heap, the dynamic memory, so here is the stack, and over here is the heap, which we don't know how much it will be. There is a way to create a multi-dimensional arrays, basically by using pointers once again. So if I want that to be my memory and everything inside my memory to be of numbers, then I would use an int, and I would create a star array. So this array is going to be, what? Well, this array is going to be a new int of, let's say, 10. What will happen? You already know. Well, I will have an array. Here is array. This is basically the address of the first element. And then I will have 10 integers inside it. So we're always starting from 0. 0, know that. But if I want, I can write down 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So how much are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are 10. But keep in mind that the elements inside array start from 0. Just, we're once again not covering that, but you should know it. But what happens if I want to double, make it a double kind of a pointer? Well, then I would need to point, this pointer is basically a pointer that can, a pointer, maybe we did not give the full explanation, but a pointer is a variable that can take the address of another variable. So what we can do? I can do, whatever the hell I want. If I want, I can do that. We haven't spoken about that, but I can do as many char. I don't know if it is spelled okay, but I can do as many pointers to whatever the hell I want. So over here, what we're doing is basically we're assigning a pointer that is pointing to pointers that take up to, we don't know how much space, but we know that this space should be of an amount of, let's say, 20. But what is that 20? Well, that 20 will be actually an array in that direction, basically, of 20 addresses that can store up to a certain amount of integers. And how we're going to do that? Well, that's why we should always study for loops. Well, for int I is equal to 0, I is less than, well, we don't know how much, but let's say we've declared that we want width and height, and they are definitely integers because we cannot have you know, number that is not is showing half of space. That's impossible. So for I is equal to 0 and I is less than let's say the height, we want I plus plus. And what we're going to do is that for each and every integer, we are going to, I don't know, either see, well, we can do a console input of those, of these arrays and the I of it, and it will be equal to, oh, I'm sorry, here we're only declaring, give me a second. So we were at the part where we want to insert or loop throughout all of this, and we want to create that each and every array of I, which is basically the address. We want this address to be equal of a new integer of, let's say, the width. And that's how, as you can see, we actually managed to show that the width that we declared, which might be, and of course this is the height already, we want to represent it that it's somewhere here, and the width might be, as we say, 10, and the height is going to be 20. So as you can see, we used the new keyword on many locations, so keep in mind you should always delete the allocated memory, which you can see at this very moment is much more, which can become much more throughout the time, and we have to delete it, otherwise it will be there for, you know, infinity time of time, and there is no way that we can retrieve it after we have closed the program or finished the execution of whatever we're doing, because it will just stay there because we wanted to use it, and now the value of whatever we used it for is going to be still there. So hopefully that made some sense over here, and why it's important to know what the ability of C++ is and how we should do it. So the last and only thing that I want to mention before ending this is that This is, as you can see, only the surface of what we'll be covering. There is much more, and I'm not sure if I should even mention it at that point, but for example, if you have for instance function that does something, and this function can be passed another function. This is a higher function, and this higher function can be even a reference, or could be pointing to the actual function. So there is, as you can see, the example that I gave earlier with passing only variables that point to certain place in the memory. It can be the stack or etc. And if we pass the value by reference, it is also possible, just like with pointers, just like with the reference, and it will be still valid because it will point to the same address, but then inside the actual we already talked about the formal and factual. We already talked about the those inside functions. The factual variables that we pass should be passed by the address. So this is something that you should keep in mind. So for example, if we're still using the add function and we declare it so that it accepts pointers instead of references, we have to pass the address of A, which we talked about earlier, and the address of B. So the same is, just because we're all we're talking about are the actually memory addresses and etc. when we're working with such language that can actually dig into the operation system, dig in its memory and use anything from it. So the same is valid for functions as well. Imagine if we had function here, which also reallocates memory inside the stack. Well, we're not going to use only one variable, but we're going to use the space for a whole function and everything that it needs in order to operate. Well, that's everything that we should cover for today. This is just the first introductory explanations of what you might come across in your very first few courses in your bachelor for computer science. And trust me when I say you definitely want to have some prior knowledge to all of that before you actually start working and studying such subjects, because it might become pretty difficult pretty fast, and you just, believe me, have to be on top of it in order to understand it. So yep, thank you very much for watching. As always, my name is Filef, and you can always write down a comment and ask me any type of question. I would be more than happy to answer, and if there's something that you don't understand from my drawings, well, I'd be more than happy to explain any of it in much deeper level, as long as I have a little bit of free time. And thank you very much, and see you in the next lesson.